Welcome to a continuation of 5.5 properties of logarithms. So I'm just doing this in my spiral. If you guys can hear that beeping, I was waiting for it to stop and it's not stopping. So I hope you can't hear it, but if you can, I'm sorry. If you can and it's annoying you, now you can just welcome to my life. Oh, it stopped for a little, but then it starts again. It's fun. Okay, 5.5. So this is just going to be using the rules that we did in the last video and basically applying them to example problems, because the example problems we did are like on the organizer are kind of basic. So we're going to use a little bit more complicated ones. So if you guys have your organizer, get it out, use it. If it's already glued into your notes, that's fine. But maybe just like take a quick look at it, because we're going to be applying those properties into our examples throughout. Okay, so one of the first things that you're going to be asked to do is to condense the expanded form into a single logarithm. Again, using our properties. Just reorganizing my table here. Okay, so we are going to write the instructions, condense into a single logarithm. Okay, so what we're going to do is I'm going to actually write kind of the order I do the rules in. I'm going to write it here, and then I'm going to do some practice problems after. This is kind of the order that I always follow. It doesn't work for every single one, and hopefully we'll talk about some of those, but for the most part, you can follow this order every single time and you'll get the right, answer. Okay, so first thing we're going to do, always, I guess I'm going to write order of steps. The beeping's going to be the death of me today. Okay, so first thing you're always going to do is you're going to apply the power property. So I'm just going to put the power property. And remember, that's either moving the power from the front to the back to the front, or vice versa, front to back. Okay, second step is going to be to change any fractional exponents to roots. So like 1/2 as an exponent is the same as the square root. So if you have any like 1/2 exponents, you would change it to a square root. If you had a 1/3 exponent, you would change it to a cube root. 1/4, fourth root, so on and so on. Okay, so then you're going to apply the product and the quotient rules. And really you don't have like those you won't have like both. Well, no, you might have both, and we'll talk about that. And then last step is just simplify any logs if possible. So simplify logs if possible. Okay, so let's do an example. I'm going to do the first one here. So that's going to be log base 3 of x plus 2 log base 3 of y. So we're just going to start off with kind of a basic one and kind of increase the level of difficulty here. Okay, so first thing I would do is see, are there any numbers out front that I can move to power? So power property, like I said, is our first step. So there isn't a number here, but there is a number here. So what we're going to do is basically undo the power property. We're going to move it as an exponent. So that is just applying the power property. So log base 3 of x plus, now that's going to become y squared. We would then change any fractional exponents to roots. We don't have any. We have an exponent of 1, an exponent of 2, so we can't do that. Then we apply our product or quotient rule. These are adding. So we see, make sure, do they have a common base? They do. You won't have problems that don't. And so they're adding, so we combine them by using what? When they're adding, we combine them by multiplication. So it would be log base 3 of x times y squared, which we don't have to put that multiplying in between. And then simplify if the logs if possible. I can't simplify that. They're just variables. So this is my final answer. And now, in case you're wondering, they are now putting trees, which I feel like I've told you guys this. This is actually my biggest, like one of my biggest fears is seeing trees go into a wood chipper. If I haven't told you why, just don't worry about it. It's just I'm crazy. But so now they're putting trees into the wood chipper. So it's like we're in zero period when our friend comes around in the morning. I'm sorry. Like I'm gonna close all my windows. I hope that helps a little bit. So I closed all the windows. So now I'm just in like a death trap of heat. But that's fine. Okay, so let's try another example. Let's go into 2 here. Okay, so we are gonna have 2 log base 4 of 9 plus 3 log base 4 of 2. Okay, so what I want you guys to do is I want you guys to try this problem on your own. Simplify it as much as you possibly can, and then come back and check your work to see if you did it correct. So pause here, try as much of it as you can, and then come back and see how you did. Okay, so you should be coming back. I'm going to still go through this one since I know it's still fresh, so you might still need an explanation. If you don't, fast forward through me. It's like the perks of distance learning. You guys can fast forward through me explaining stuff. Okay, so first thing I would do is the power property. I'd move the 2 to the 9. I'd move the 3 to the 2. So that would be log base 4 of 9 squared plus log base 4 of 2 cubed. Now 9 squared and 2 cubed, we know what those are. 9 squared is 81, 2 cubed is 8. We can simplify those. Unlike here, we couldn't simplify because it's a variable. Okay, now I change any fractional exponents to roots. I don't have any. So then I'm going to apply my product and quotient rule. So they have the same base and they're adding. So we're going to combine them using multiplication. Log base 4 of 81 times 8. I can simplify that. I know what 81 times 8 is. It's 648. And you have 2 options here. You can either leave it like this, or we can solve it. We can actually solve this one and get the rounded answer. So you would have 2 ways of writing this, and I'm going to explain what each one is. So if we were to actually get the decimal form, So if you wanted to use like change of base, you could. So that would be ln of 648 divided by ln of 4. Remember, you drop the base. Or you can go in, if you have a TA84, TA84 plus, whatever you have, and go down, and that would be log base 4 of 648. You get the same thing. Now, there's two answers. So this is going to be simplified is 4.6 7. I'm just going to round it to 2 decimals. Now with this, so in the book or on like a test or something like that, you have two options. This is the exact value because this is the rounded value. So if it says find the exact value of this log, it would be this answer. If it says find the rounded value, round it to however many decimal places, this is what you want to do. And all we did is use our calculator. I think the beeping is signaling that they're using a chopper and to stay clear of the chopper. I don't know, but it's great, guys. It's great. Okay. So let's try another one. Okay. So if I have 3 ln PQ plus 4 ln PQ squared, I want you to think, okay, what's my first step in doing this problem? So what would be the first thing we would do? And if you're thinking power property, you would be correct. So we're going to move the 3 over. Now the 3 is going to be outside the parentheses there. And we're going to move the 4 over. Also, the 4 is going to be on the outside of the parentheses. So that means it's going to be ln PQ cubed plus ln PQ squared to the 4th. Now, at this point, what would you guys do to make this simpler? And if you're thinking distribute those exponents, you would be correct. So we actually do want to distribute the exponents to make this simpler. The 3 to the p and the q, and the 4 to the p and the q squared. So that would become ln p cubed, q cubed, plus ln p to the 4th, q to the 8th, because we're multiplying. Power to a power, we multiply. Okay, so then what do you think our next step would be now? And so if you're thinking use the product or quotient rule, you would be correct. So this is adding, so we're going to combine them using multiplication. So that would be ln of p cubed, q cubed, times p to the 4th, q to the 8th. And then from there, what do you think your next step would be? And if you're thinking combine like terms, again, you would be correct. P cubed and p 4th can be combined. When we're multiplying with the same exponent or with the same base, we add the exponents. And q cubed and q to the 8th can be combined. So my final answer, 3 plus 4 is 7, and 3 plus 8 is 11. And so that would be my final answer. Okay, So let's move on to another problem here. Okay, so let's do number 4. Yeah, 4. I know these are a lot, but there's just a lot of variations to these that I want to show you as many as we can so you kind of feel good with these. So let's try this one. So we have 1/2 log base 3 of w to the 4th minus log base 3. Oh, that was supposed to have a 2 in front. Sorry. 2 log base 3 of x plus 5 plus 3 log base 3 of y to the 3rd. Ooh, that's a lot of 3's in there. Okay, so with this one, first thing, what's our first step? Okay, so if you're thinking power rule, you're correct. We'd bring the 1/2 to the 4, the 2 to the x plus 5, and then the 3 to the 3. Now what's happening with these is we're multiplying. It's a power to a power. So when we multiply 1/2 times 4, it actually turns into 2. Because 4 times 1/2, it's like a power to a power. And multiply, it becomes 2. And then minus log base 3 of x plus 5 squared plus log base 3 of y to the 9th. Power to a power, we multiply, so 3 times 3 is 9. Okay, change the new fractional exponents to roots. My fractional exponent turned into a whole number, so I don't have to worry about that. I'm realizing that I don't have any examples of that in this one, so maybe we'll do one more. And then my next step would be to do the product and the quotient rule. So I look to see what's positive and what's negative, because we have some positive, we have some negative. Whenever it's a positive, it's going to go in the numerator. So it's going to go on the top. Whenever it's a negative, it's going to go on the bottom. So this is a plus, it's going to go on top. So the way that we would write that is log base 3. We have some stuff on top, some stuff on bottom. Remember, it's all part of one log. So w squared and y to the 9th is also on top, all over x plus 5 squared. Now, I would not multiply this out. There's no point. If you could factor something, I would probably factor it, but this is already factored, so I would leave it as that. And that is my answer, actually. And that is it. I'm going to show you the I'm going to show you the exponential, like the fractional to roots in the expanding. So let's get to that, because I know you guys don't need my prolonged, more and more and more examples. So move this a little awkward. Okay, so we are going to then rewrite as a sum or difference of logs. That's my expanding versus condensing. So rewrite as a sum or difference of logs. And we'll do kind of our order of our steps, just like we did with condensing. And really, the order of steps is just the opposite order of condensing. So we started with like power rule and then changed fractional exponents to roots, then the product and simplify. So the first thing we do on here is to basically like apply the quotient and product rule. So product and quotient rule. And then after that, we kind of like move it backwards. We change any roots to fractional exponents. And then last step is to apply the power property or power rule, or I feel like rule and property are synonyms, so who knows? I don't know. Okay, this is like the document camera. I feel like I can do this. I'm gonna be a forward thinker. My arm, on the document camera extends so I can use that. Okay, so let's do an example. What would we be on 5? Okay, so you know what? I'm just gonna get into a doozy of one, because why not? Okay, so if I gave you log base 8 to rad x divided by w y to the 4th. Okay, so like I said, doozy of one. Maybe it's not great. I honestly like the more you know your properties, the less of a doozy these are. These are like super straightforward. There's no change really. So I look, there's 1, 2, 3, 4 things that we're going to separate. So this is going to be, it's on top. So that means we're going to separate it using addition. This is on top. We're going to separate it using addition. W is on bottom. So we're going to separate it using subtraction. And y to the 4th is on the bottom. So we're going to separate it using subtraction. So top is always separated by addition. Bottom is always separated by subtraction. So let's write that out. That would be log base 8 of 2 plus log base 8 of rad x minus log base 8 of w minus log base 8 of y to the 4th. Okay, so now we want to change, so we expanded, so we used the product and the quotient rule. Now we want to change any roots to fractional exponents. So here, I'm just going to circle that like a weird thing. And we're going to change that square root to now be a fractional exponent. So a square root, remember, is the same as a 1/2 exponent. So that would be, all of this would stay the same. Log base 8 of 2. And then this would become log base 8 of x to the 1/2. And then log base 8 to the w minus log base 8 y to the 4th. Okay, and then we changed any roots to fractional exponents. Now we're going to apply our power property. No power here, we're good. That 1/2, we're going to move it to the front. No power here, we're good. That 4, we're going to move it to the front. And then that's going to be my final answer. So log base 8 of 2 plus 1/2 log base 8 of x minus log base 8 of w minus 4 log base 8 of y. And that's it. That's my answer. If I could simplify this, which I can't because we don't know 8, well, technically this is 1/3, but I would only want you to do it if it was whole numbers. But 8 to the what power is 2? Well, it's 1/3. But let's say it was like log base 8 of 64. Well, we know 8 to the 2nd power is 64, so we would convert this to be a 2 instead of log base 8 of 2. That would be the only different thing you might see here. But this is my final answer. And that's it. I'm going to do just like 2 more on rewriting, so expanding. So I'm going to turn my page. And I already forgot what number we're on. We're on 6. Oh, there it is. Okay. So let's get to 6. Okay, so this is going to be log base 2 of y over z to the 5th squared. Okay, so this is a little different. We have a power already in it, and there's 2 ways that you guys can do this. You can like bring this 2 out to the front, but then when you separate it, you'd have to like have it be a part of every single one. What I actually like to do is distribute this 2 from the beginning. And so distribute it in to my argument to the top and to the bottom, and then expand after that. So this would be log base 2 of y squared over z to the 10th. So we just power to a power, we multiply. This is a 1. 1 times 2 is 2. 5 times 2 is 10. So then what I want you guys to do, pause me from here, and I want you guys to finish this problem on your own. So expand this one on your own, and then come back and check your work. Okay, so let's try this one. So you should have already tried this one on your own. So top means we're going to be adding it. Bottom means we're going to be subtracting it. So when I expand that out, that's going to be log base 2 of y squared minus log base 2 of z to the 10th. I should never use z's. And then we're going to apply our power property. 2, it's going to go to the front. 10, it's going to go to the front. And so that would be 2 log base 2 of y minus 10 log base 2 of z. And that's it. That's my final answer. So really, no matter like how big or small the problem is, like 5 wasn't really like, it looked a lot bigger. You do the same thing every single time. It's the same order. There's nothing like crazy or out of the ordinary with these. So, okay, let's do one more and then we're going to be done. Okay, so number 7. Okay, for number 7, we're going to do 1/4 ln of x plus 2 to the 8th power minus ln x to the 10th plus 2 ln x. Okay, so if you guys want to pause me here, try this one on your own. Great. If you want to just watch me do it, that's fine too. We're going to be doing a lot, like expanding and condensing comes into play in the next section a lot. So it's something that, we use it over and over. So first thing I would do is undo my power rule. So the 1/4 comes to the 8. There is no number in front here. And then the 2 is going to go to the x. Okay, so 1/4 times 8 actually just gets me 2. And then this doesn't change. And then this changes to ln x squared. Okay, so then we want to apply, we would change any fractional exponents to roots, but we don't have any. So then we're going to use our product and quotient rules. So if this is a plus, this is going to go on top. That's not what I wanted. Sorry, I wanted to write top, not plus. So this is plus, so it goes on top. Minus, this is going to go on the bottom. plus is going to go on top. And so that's going to be ln, we're writing it as 1 log, x plus 2 squared, x to the 10th goes on bottom, and then x squared goes on top. Now, is that it? Is that my final answer? And the answer is no. I can actually do more here. The x squared and the x to the 10th, I can simplify those. So I'm going to do that. Remember, when we have the same base and the powers, like same base, we subtract the powers. So this is going to cancel out to go away, and then this is going to cancel to be 1. Or, sorry, 8. So simplify any like terms, just like we did on that prior example. So my final answer would be ln of x plus 2 squared all over x to the 8th. You can't simplify these because remember, this would be like multiplied out. There's a plus in between. Can't simplify anything that's multiplying with something that's adding in between. So that would be my final answer. And that's it. And so what I was saying with this one, like how it simplify any like terms, it's just like 3 that we did. We simplified any like terms here. We combined here and here. We combined the q's. Same exact thing here. We can simplify the x and the x10. And that is it. That's all I'm going to do for this. So again, if you guys have any questions throughout this and like, you're confused with any of the notes, anything that, you want to go over, please like call me, text me, email me, come to the Google Hangout. So many ways that you guys can get in touch with me. So don't like stay confused, you get the help that you need. And that's it for today. I hope you guys have a great day. I have also been, I know you guys, pins and needles since the last update on my television watching. I've been also watching to the Listen to Your Heart on Bachelor, the Bachelor one. For those of you that, watch it, there's 2 things I'll update you on. One, I've been watching that. Not my favorite, but it's okay. And in the fact that it's still something Bachelor, since we're not going to be getting Claire's season for a while. Not that I'm excited about, well, I don't know. I have mixed feelings with Claire. But anyways, so I don't know how I feel about Listen to Your Heart, but I'm still watching it. I yell at the TV a lot. That's normal. And then this whole Peter and Kelly thing, I'm really just, I don't know. I'm going to be completely honest. I've seen Peter's TikTok, and that is just like the most cringe-worthy thing I've ever seen in my life. So that's my update on the Bachelor scene. Listen to Your Heart is, good if you're bored. And don't ever watch Peter's TikToks because they are just, it's just so embarrassing. So there you have it. There's your update. Hope you guys are doing well. And miss you guys. And let me know how everything's going. If you guys need anything ever, just, let me know. Happy to help. Bye, guys.